It's like the prequel to my presentation.
I was practicing earlier, so I have to undo all the stuff I did. I hope you guys are excited about some Excel. It's exciting to me, and I hope I can make it exciting to you as well. Let's see, so how does this work here? I'm kind of new to this. Play, is that what I want to do? I think that's what, yes, there we go, okay. But can you see if I have notes? I can't see either, okay, cool. Anyway, I'm Rico. I'm currently a Rubyist, but today I'm going to talk to you about how I got started with programming. So that does not start with Ruby, unfortunately. My first exposure to programming was in college. I was actually a business major, but I had an option in computer information systems. So I had basically an intro to C++ class and an introduction to relational databases class. And that was the extent of my exposure, but it was, what's the right word? Formative? I'm not sure formative is the right word. It really stuck with me. I think that there is something fundamental about decomposing work into the primitives that we get in a programming language, like variables, conditional statements, and loops. And I think that there's something sort of fundamentally true about modeling the real world in relational databases. And even though I just had like a really brief introduction to those two topics, it really stuck with me. And sort of informed how I thought about the world. I'm very much a systematizer. I like to see how things connect. I like deep Wikipedia dives. I like reading about history because that sort of tells you how things connect. So I think you can understand when I had this sort of systematic tool for understanding how to break down work into fundamental units or to how to model the real world, it definitely stuck with me. A well-rounded, normal, like well-adjusted person would have come across that and decided, hey, maybe I should change what I'm doing and follow this thread, you know, keep pulling at it and see where it goes. But that was not me, because the reason I was a business major is because it's the easiest way to get a college degree. There's very little math, and there's very little writing. And the technical subjects are basically like accounting, which you could go learn double entry bookkeeping on Wikipedia in like 20 minutes. Like seriously, it's not that hard. And so I basically did not, pardon my language, but I did not have my shit together. For me, college was just about getting through it and getting a degree so my parents would get off my ass. So I was busy taking the path of least resistance, and I just let this golden opportunity like really just kind of float right past me, and I didn't do anything about it. And I wandered in the wilderness for a long time, for 8 years actually. Those were an important 8 years because I needed to get my shit together. But it took a long time. And, you know, life is this way where, in retrospect, you always wish you'd done a few things differently, and that is one of them for me. There are a couple others, but I'll spare you the emotional baggage. So finding my way back, eventually, after a long detour, a long winding road, working construction, doing all sorts of weird stuff, I ended up working at a company. They're still a client for me, actually, to this day. Almost 10 years ago, and I started working for them as a customer service person. So they sold goods to contractors, and my job was literally to sit behind a desk, and people would walk in and want to buy stuff, or they would call on the phone and want to have stuff delivered to their job site, and it was my job to make those things happen. But I started there in May of 2008, and the housing market basically imploded 3 months after I started. And somehow I managed to be one of the remaining 3 people of the company. And the company at that point was 3 people in a room. It was me, the owner, and the owner's girlfriend. So when you're in a company that consists of 3 people in a room, everybody wears lots of hats. And one of the hats that I got to put on a regular basis was making sure that we had enough product in stock. And it is by this long circuitous route that I made my way back to programming. Because as part of wearing that hat was spending a lot of time with Excel. So I'm going to show you some stuff in Excel. And the thing that I really want to communicate is that I'm sure most of you have used Excel. Some of you have probably used it exceedingly well. But most of you probably, have used it just to like make a list, basically. I mean, that's at its basis, that's what Excel is. But it's actually like a lot more than that. And by sort of going down this rabbit hole of becoming sort of a hardcore Excel user, I got exposed, well, that's a better way to put this. It terraformed my brain and prepared it for programming. And so I kind of want to show you some of that because it's very interesting to me, and I hope it's interesting to you. So having to hold the microphone is going to be a little tricky because I meant to do like a demo. Is there a good solution here?
I need an assistant.
Yeah, Tim, would you be an assistant for me? Sure. Thank you. Okay. Okay, so basically what we're looking at here, let me full screen this, and we'll pump up the size a little bit. There you go. That looks decent to everybody? Okay. Cool. So what we got here is we have a list of products, column A, and then column B, we have the units that we're selling per month for each one of those products. And then column C, we have an inventory target. So that's basically how much inventory do we want to have on hand at any given time. Basically, it's a pretty simple formula. You just take the monthly sales times 2. So basically, we want 2 months of inventory on hand at any given time. Pretty simple. Now, this is how much we have in stock of each one of these items. So we're going to make like a really basic replenishment spreadsheet. We're just going to go through this together. So basically, to figure out how much we want to order, we're going to take the amount that we want to have, right, minus the amount we actually have, and that should give us a result, right? So one of the first things that Excel did was it got me used to basically manipulating work and algorithms like with numbers on a computer, basically, and that all happens in this formula bar. But Excel has some amazing things, so we can just take this formula, double-click there, and it'll come down. One of the coolest things about Excel that I really love is if there's a problem in your algorithm, you see it right away. Like, for instance, we can't order negative items. It's not possible, right? What's going on here is we want to have 24 of this item in stock, and we have 32. So we have more than we need, right? So since we're just doing basic subtraction, we get a negative number. And we see that immediately. Like, you can see the data. So imagine doing the same thing in Ruby. You've got your collection of objects, right? And you do .each. And then you iterate over each one of those and you do something, but you don't see the intermediate results in Ruby. All you see is whatever you output at the end, and then you get some cryptic method like, there's no negative on nil or whatever, and you're like, geez, I don't know, I just iterated over 1,000 items. I have no idea where this came from. But in Excel, it's right there, like there. You can point to it, and you can look at it, and then you can sort of trace back, and you can see, as we did in about 2 seconds, what the problem is here. This is also where my first exposure to conditionals came in. So we're going to fix this problem real quick. And what we want to do here is we basically want to say, if the amount we have in stock is greater than the amount we want in stock, we don't need to order anything, so we're going to put 0 here. Otherwise, we're going to do the thing we did before. And we'll take that, and we'll copy it down, and boom, again, immediately we can see this works, right? We have 0 where we want 0. But I want to stop for a moment on what we just did here. So this is a conditional, but if you're used to languages like Ruby, this doesn't look like most conditionals that you've seen. You're used to conditionals that are part of the syntax of the language. If whatever, then do this, else, end, right? But here in Excel, there is no syntax. Everything is just functions. So what we're calling here is an if function, and then it takes 3 arguments. The first argument is this Boolean expression, which is going to evaluate to true or false. And then if it's true, you do this, it'll output the second argument. If it's false, it'll output the third. Now, whatever, you can sort of see the mapping. It's not that big of a deal. But if as a function is kind of a weird thing. And many years later, how many of you have done the, the SICP book? Nobody? What is it? Some people, right? So there's this book. It's kind of a famous computer science, like intro to computer science book. You can look it up. It's like a free course from MIT, I think. And they teach the course in Scheme, which is a version of Lisp. And another interesting thing about Lisp is that everything in Lisp is a function, including the conditionals. Like when you dive into it, it's a special function, but basically it's a function. You, rather than having like an if statement that's part of the syntax, you just have an if function, and you could, in theory, overwrite that if function. By the way, I'm pretty sure you could also overwrite the if function in Excel. And interestingly, if you go look at Lisp, this will look incredibly familiar. Well, at least it did to me. I was like, hey, that looks like Excel. The only difference, literally the only difference, is you just take this if here, and you put it inside the parentheses. I'm sure most of you have heard that Lisp is notorious for parentheses. That's basically Lisp right there. So that's one way in which, oh, it doesn't want to do that. That's one way in which Excel sort of like terraformed my brain and prepared it for the programming future that was ahead of me. Now imagine we've already placed some orders with some of our suppliers, and we have some products incoming. So in this case, our original calculation is we have 52 items that we want to have in stock. We have 19 in stock, so we need to order 33. But we have 10 incoming, so really we don't need to order 10 of these 33 because we have them on the way. So let's modify this, and rather than subtracting 19 from 52, we're going to subtract the sum of 19 and 10, right? And that looks much better. And then we'll copy that down. And oh, boom, again, hey, we have a negative number, right? So Excel's telling us, screaming at us, that we have a bug here. And the bug, if you're sort of keeping track, is that we are accounting for the incoming column in the result, but not in our comparison here. So when we're looking to see if we don't need to order anything, we're not taking into account what we have incoming. But then when we go to do the calculation, we are taking into account. So all we need to do is we just need to use this sum here, right? And we'll take that, and we can copy that up. But anyway, we fixed our bug, right? So we're back to where we started. At this point, and I know some of you are probably looking at this and thinking that, hey, something is wrong here, which there is, which is that this violates the dry, do not repeat yourself principle. Because we're doing the same operation in two places here, right? We're summing these two numbers in two separate places. And usually when you're doing the same thing over and over again, it's an indicator that there's some fundamental truth encapsulated in that operation that you should be doing only in one place and then referencing that result everywhere else instead of redoing the calculation. Because what happens is as you go on, things change, and then you have to remember to update things in lots of places. So this was my first exposure to that. And having to solve problems like this was my first exposure to named variables. So in Excel, but if you might be wondering, like, where the heck do we put named variables, right? Because there's no place, you can't, everything's a function. There's no place to declare variables in here. And the answer is that in Excel, variables are just other cells on the spreadsheet. So what we're going to do here is we're going to make a quote-unquote variable, which we're going to give a name to it called available. And this is going to be simple. It's just going to be sum of this and this, right? And then we'll take that and we'll move it down. And here we can now take the sum thing out of here, and we'll just reference our available column. Now we're set up because what's going on is I can tell you from personal experience, and I'll show you the actual real spreadsheet that this is like a little mock of after this. But this available calculation can get extremely complicated, like anything, right? You start off with an initial version, then as you go through, you realize, hey, this problem's actually a lot more complicated. I need to change all this stuff. Well, now, just as in like Ruby, where you might have one place where you're deriving how much, in a hypothetical scenario, how much you need of something, we're doing the same thing here, and we can modify it all we want, and it's just going to flow through to everything else. So here, yet another example of how basically getting good at Excel started terraforming me, my mind, and getting me ready for programming. By the way, another interesting thing about Excel is, so we gave this, let's treat the column headers as variable names. An interesting thing about Excel is other people look at your spreadsheets, which means that you have to give your column headers good names, which means that you get practice at being good at naming things, like naming variables in a way that makes sense. So if you write some code that you know nobody in management is ever going to look at, you can do whatever you want with variable names. What the variable names represent can change over time. You cannot update the variable names. So you end up with this mismatch between the name you give to something and what the thing actually is. But when you have something that's regularly reviewed by other people, if they go and say, I don't understand what the name of this column is, like what does that actually represent, it forces you to get better at naming things. So yet another example of how like my brain was being prepared for programming. Okay, so the last thing I want to show you is imagine that, well, okay, if you're buying goods from a vendor, I can tell you that they don't want to sell you ones and twos. They're going to get the products. They're either going to have it manufactured or buy it from somebody else. It's going to come in like some larger quantity. So, for instance, you might only be able to buy something in quantities of 10 or 20 or 15 or whatever. So for our little replenishment demo here, we want to pull in the ordering. We'll call that the ordering multiple, right? So and we're going to pull it in from somewhere else. So we don't have that here. But we do have it on this other tab. So same list of products, right, with the product ID, ordering multiple, and price, which we're going to ignore for now. And we need to get that over here, right? So you'll see why in a second. But we're pulling this in here. And if you look at this formula, you can see how I didn't want to try and live code that. But it's actually pretty simple what's going on here. And I think that this is one of the most interesting things, for me at least, is that, so basically what's going on here is there's an index function, and it takes 3 arguments. The first argument is a 2-dimensional array of values. The second argument is the vertical coordinate that you want, and the last argument is the horizontal coordinate. So you're basically saying, hey, here's a grid, a 2-dimensional grid, and then here are the coordinates to find the value that I want. And so in this case, what we're doing is we're going over here and we're saying, hey, this is our 2-dimensional array, and then there's something that basically finds the right row number and then the right column number. And those are this match function. And what this is, it's super simple. All this going on, the first call to the match function is taking this product ID, and it's just going over here and saying, hey, in this column, find me the row number of that column ID, or of that product ID that matches that product ID. And then we're doing the exact same thing for the second match call, which is going to provide the horizontal coordinates, except for we're just taking this value up here, ordering multiple, and then we're looking for it in this row right here. So in this case, for that first item, it's going to return, the first match call is going to return row 2, right? And the second match call is going to return column 2, and it's going to return this value, 8, right? And we've done that here. What does that look like to all of you, what we just did? It is a left join. Yay, I did a manual left join in Excel like years before I would ever do like an actual left join in SQL. Yet another example of like how my brain was being sort of readied for all of the for programming. And interestingly, that's just one specific example, but Excel is a table-based tool, right? Excel wants things to be in tables, especially the way I was using it, which is a list of, like a collection of items, in my case, a list of products. And eventually, what I built turned into a network of like 15 different spreadsheets, all sort of like factored so that each one would do its own thing or whatever. So I was doing these left join operations like all the time. Basically, I'd have one spreadsheet that was meant to do product ordering. It would pull in a bunch of product attributes. It would pull in like our current on-hand inventory from another spreadsheet. It would pull in like forecasting data from another spreadsheet. And so I got like really good at doing stuff like that and thinking in terms of tables. Like how does data in one table relate to data in another table? So we'll just end this. We'll finish out this exercise real quick because I don't want to like leave it undone. So we have to order in multiples of 8. So what we're going to do is we're going to take the amount we want to order divided by the multiples that we are allowed to order in. Obviously, we can't order 2.875 cartons. So we will just take this Everything's a function. We'll just round it to zero digits. Okay, so we want to order 3 cartons, we'll say. And then just to finish it out, that works out. We have to place our orders in terms of units, so we will just convert that back to units. And this is our finished order. I didn't want to leave that hanging out. That's actually not super necessary. But that's why I'm a programmer. I don't like to leave loose ends. So anyway, that's just a few things that I thought were kind of cool about my days with Excel. One other thing that's super interesting is, say for this inventory target here, right? We're just doing ×2, but let's say we want to make that variable, right? So we're going to put the number 2 up here, right? And then rather than just having a number in here, we're going to reference this 2 up here. Make that an absolute reference. Wait, no. This 2, by the way, go back to terraforming my brain. That's a global variable right there. Say we want 3 months of inventory. That changes our order, so we can just change this. So everything in Excel is a function. As you change stuff, the changes flow through to everything else. So it's functional and reactive. And another thing that it is you can't actually mutate anything. You can't change anything. So if you have this value 26 in this cell, there's nothing you can do in any other cell on this spreadsheet that will change the value in that cell. So interestingly, I didn't know what any of these things meant. But many years later, I learned, oh yeah, I already have experience with a functional, reactive, immutable programming language. So boom, there you go. The real version of this spreadsheet is way more complicated. I'll just show it to you here because it's my baby. This is my original software app. It has been in continuous use for about 9 years at this point. I'm not using it currently. Other people who are doing my old job are doing that. But you can see that it is a lot more complicated. There's a lot of columns. There are a lot of rows. It's meant for ordering containers from China, so there's all this crazy configuration you can do with containers. And that's just the UI part of it. There's like all this other stuff that goes to actually support the UI. It's pulling in data from like maybe 4 other spreadsheets. And this thing, my baby, the first thing I ever made, this has been used to order like about $20 million worth of products. So yeah, so that's how I got started. I ended up in Rails finally. And I made a little detour through Perl, and oh, you're laughing now. Okay. I made a little detour through Perl. I needed to do some shell scripting, make some things to manipulate some data. I did the WordPress PHP thing, but you know that was enough to sort of get me exposed to web development as a discipline, and then I realized, yeah, I want to be doing Rails. So I love Rails, but sometimes I miss Excel. Thank you.